I'm really interested in this because we've like kind of had a poor man's alloying with the Oracle. like
Yeah, that's true.
using the strengths of Sonnet to generate stuff quickly
Yep.
and like get something working, and then
Yep.
using the reasoning power of O3 to kind of be a second opinion.
All right, so we're here with another edition of Raising an Agent. This time we're going to be talking about how we evaluate different LLMs and models. And so I got Camden from the AMP core team here to talk through how we've been doing that. Camden, how are things going?
Things are going great. It's an exciting week for model developments and really, I guess, a few weeks of lots of interesting stuff going on.
Yeah, definitely, definitely. Yeah, so I guess to kick things off, for people who don't know much about AMP, do you want to talk about like our philosophy related to what models we use and how we use them?
Yeah. So AMP is a little bit different in that we build something that takes the best of models across the industry, not just from a single provider, and slot them in to build a product that is, as a whole, more effective at coding.
Yeah. And so what current models do we have like running inside AMP?
Yeah. So our primary model right now is Sonnet 4. This is the one that drives everything else. And then the other models that we use are we've been using O3 for our Oracle agent. Oracle is the Oracle is a like a code review and kind of planning agent. It's meant to be kind of a smart, deep thinking agent to supplement Sonnet's faster iterative behavior.
Yep.
We also use Gemini Flash for summarization as a quick and cheap summarization model. We use Haiku for title generation. And let's see. And now we can enable GPT-5 as the primary agent for testing. Haven't enabled it by default, but like we want users to be able to see how it feels.
Yeah. And this is a big kind of like milestone for us because up until now, like you mentioned, we use a variety of different models for different use cases, but up until now, we've basically just had the one model used as like the main driver for the agent, right?
Yeah. We briefly had a similar toggle for Gemini Pro.
Yeah.
But like ended up removing it when we decided we wouldn't be able to get it to the level of quality that we were getting with Sonnet.
Yeah. You want to talk a little bit about that? Because that was also an interesting moment. There are certain things that I think like Gemini Pro did really, really well, but it wasn't quite, at least for our use cases, it didn't quite get to the bar that we wanted to see.
Yeah. So I guess like to compare, Sonnet has two things that it's really good at that other foundation models have struggled to compete with. One is tool calling. Sonnet does that really well. It selects tools well. It generates arguments well. It like knows how to explore a code base and iterate well. So it like really has this kind of agentic behavior built into its training.
Yeah.
So with like in comparison, Gemini, it's really good at one-shotting. Like if you tell it like build me a website, it'll do it and it'll do it fast and well. But when trying to use it in an existing code base or on complex tasks that require it to kind of explore the code base, find what it needs to do, I really kind of struggled with that. And ultimately, like AMP is built around this iterative self-correcting loop. So an agent that can't self-correct isn't that great yet.
Yeah. It's like it was really good at, here's all the files, page them into context, and then like, write a function that does X, Y, and Z. But I remember you saying that sometimes even like the basic like tool calling schema would kind of like confuse it, or it would like get it wrong, and there'd be like a tool calling error that was completely unrelated to like anything reasoning related or high levels. It was almost just like the low level mechanics of emitting tool calls in a structured form.
Yeah, exactly. The tool calling mapper, I mean, in the tool calling API is really just a schema that you ask the agent to generate things in, and then pull the tool cards out of the schema and send them back as tool calls. And this schema that was used for Gemini, like it would fail to generate correctly formatted, like it was Python code that was generating to call these tools. And if you have a poorly escaped Python string, then that shows up as an error to our users.
Yeah. And it's like, it's one of those things where it seems minor. It's like, oh, it gets it like most of the time, but when you're in the middle of like trying to write some code, and you get this error and it like disrupts the flow, it's actually quite annoying.
Yeah, especially like when we're doing like tens of loops before the next user interaction. Like if it exits at the second iteration, then like you might have walked over, grabbed some coffee, and come back, and it was not doing anything.
Yeah. And we have someone on the team, Jeff Huntley, who loves doing it in that style, like the Ralph Hoodlum style, where it's like you fire and forget, go grab a beer at the pub, and then you come back and hope that it's completed. I think if you prompt it well, I think we've seen really good results with the existing agent that they're doing reasonable stuff. But I feel like what we used to say with chained LLM calls, so like each one is sort of a dice roll, and so if you get like 98% fidelity on the first one, that decays like 96% and then 92%, and then after a couple of hops, it quickly decays exponentially to something that is a lot more reliable. And that exponential decay, even if it's like 98% fidelity on the first call, it's still an exponential decay.
No, so the interesting thing is like that decay was really visible in Gemini, where like if it started getting off track a little bit, like that compounded. And like Sonnet is interesting in that it kind of self-corrects. Like if it sees an error, like for example, if edit file failed for whatever reason, whether that's our fault or Sonnet's fault, like it would find a way to do that same thing. And like lots of times you'll see it like pull out sed to template the file, or just like use the create file to overwrite the whole thing. Find some creative way to get itself out of the ditch that it landed itself in and kind of move forward with its task.
Yeah, it's got like multiple mechanisms for getting what it wants. I've seen a couple times, like if for whatever reason, like the read file tool fails, or actually it's like the write file, the edit file tool fails, it will like write a bash script to like cat the contents. It's like it knows enough about the tools at its disposal to find these sort of like creative workarounds.
Yeah, it is interesting. And like I think earlier on, like we spent a lot of time thinking about building an orthogonal tool set, like tools that don't overlap at all, because it would confuse the model and like it wouldn't know how to proceed. But now the model's kind of gotten good enough that this overlapping nature of the tool calls is almost an advantage, because when things go wrong, and they still do, there's different paths forward, and the models can discover those.
Yeah, it's like a human, if for whatever reason, like your editor is acting up today, like you have another editor, or you fall back to editing files by text. It's like you find creative workarounds. Cool. All right. So, we tried it out with Gemini Pro. At that point, it didn't work very well. Are there any other models that we've kind of like tried along the way as the main agentic driver?
Yeah. So every new model that pops up, I usually throw it in as the main agentic driver to test it out, because like, not because I think it's going to be useful there, but because I think that's one of the best ways to kind of learn the personality of a model. Like being up there close and personal, like using it for other things like summarization, it's all in the background. And just like you don't get to know what its quirks are and things like that. So I have like experimented with Opus. We don't use Opus in AMP, mostly because it's more expensive than we think that the improvement is worth. And
It's almost slower.
It
Big deal.
is. Yeah, yeah. And like Sonnet is good and it's good enough. And I don't think we can justify the additional flow and cost for this self-correcting loop.
Totally.
And then I've also experimented with quite a few of the new like open models. A couple weeks ago, K2 had its moment.
Yep.
And then Qwen 3 Coder is still really exciting.
Yep.
Um,
How did those stack up? Because there was like a ton of hype around those, and you saw people tweeting about it, like, "Oh my gosh, it's like so blazingly fast."
yeah. So they're quite good. Like I think these are some of the first open models that I've seen that can really do tool calling well. And so far that's kind of been the limiting factor, is if you can't do tool calling well, then we can't slot it in easily and we can't use it for semi-general use cases. So that was really exciting to me, because especially when you have these open models that do this, now you have choice in provider as well. And along with the new open model stuff, there's been a lot of improvement on like the hardware and provider sides as well. So like companies like Grok or Cerebras, like they're building custom hardware that makes serving these models super fast. And fast is kind of a dimension that as in, like the AI coding industry hasn't been able to explore yet, because really the speed hasn't been there for models that are good enough to do particularly useful tasks.
Today we're in like the 56K era of agents, I think, where it's like, you still kind of like have to wait for it a little bit. There's lag. People are almost like orienting their workflows around like, oh, this one's working. I'll let it do its thing. Let me go fire up another thing, or maybe I'll, check my app messages or something.
Yeah.
I'm
I'm excited for a couple of reasons there. Like speed, because it's so unexplored, the DX of it is also unexplored. Like the experience of how you would even interact with these could change so drastically. Like right now, it's like the kind of fire and forget. You let it do its thing, you come back. If you're really bored, you can watch it. But like in a world where you're generating 2,000 tokens per second, that is a world where we could maybe spin up 10 of them at the same time. And if 5 of them fail, who cares? Because it's now cheap. And if like you come back and one of them has the right thing and we can analyze 10 results 10 times faster, then like the self-correction has more opportunities to pick up on like the paths that are promising.
Yeah, totally.
Yeah, so that part is like a really fast but slightly dumber model. And I think that's kind of interesting for a lot of the more specialized use cases. Like specifically, we've got this code search agent, and it doesn't need to really understand the code well. It just needs to be able to sift through large amounts of files, pick out the ones that are actually relevant to the query that you're asking about, and spit that back to the primary model that does the real thinking. So this is a scenario where the speed smarts trade-off is very clearly in the direction of speed. And we can take advantage of these new models to plug it into that spot and provide a better user experience out of the box.
So I think like a lot of people will want to know, like, if Qwen and K2 were like almost there and they're like so blazingly fast, why didn't we turn these on as the main agentic driver? Like, what was your kind of like qualitative assessment of how they performed, all things considered, for the overall like user experience?
Yeah, so like I think it's exciting progress, but I think it's still very obviously not at the level that we're getting with Sonnet.
It's like 80% of the way there.
Yeah, I think that's fair.
What does 80% mean? Is it like 80% is good on each thing and then that kind of like degrades over time, or like it would work well 4 out of 5 times, or
For me, it would work well on 4 out of 5 like mini tasks. So like problem is that like a larger task that I give it is composed of tens of mini tasks.
Yeah.
So like if you were to like say edit this file to add comments or like modify this function to do X, then like 4 out of 5 times that would work well. But if you're saying design, build, test this feature, then that's a handful of tasks, and it gets into this exponential decay, or the multiplicative decay problem that we're talking about.
It's really interesting because I think it's like it really depends on like how many hops is your ideal use case. Because I feel like right now there's this gap that I see in the world of people using AI dev tools where like some people are still very much in like the AI IDE modality, which is like human in the loop at every single turn. And then other people have made the leap to like full agent mode, which is like, hey, I'm going to have this write, 95% of my code. I'm just going to instruct what to do. And it's almost like if you're coming from the, like, I approve every single file change and tool use, I'm like in the loop with the model. It's like the open source models are probably like hot, they compare very favorably to what you've been using. But the people who are in like full agent land where we are, it's like a little bit of degradation means that I can't fire and forget. Right. It almost like pulls you back into the old school. I say old school, it's like 12 months old, but like
I mean, it's kind of this self-correcting loop. Like if you have the right feedback, then these open models can be great. But like right now, the human is kind of the fallback feedback. So if you don't build out the tests or the type checking or the linting or whatever, then the human has to be the one that gives the agent the input to like fix itself. So at that point, having an agent that gets that last 20% is really important.
Yeah. It's like that last X% to make the exponential decay, across, I don't know, like 100 iterated tool calls, there's like some threshold at which it flips. Okay, cool. So like our assessment then is with like K2 and the new Qwen model. See potential there to power like the narrowly scoped subagents for like search and retrieval, but they're not quite there yet as the main agentic driver. But now today GPT-5 is out. What do you make of GPT-5?
Yeah. I'm excited about GPT-5. I think it's like a good general model. So like that's what it's supposed to be. So I'm glad. But I think the thing that excites me is like we talked about tool calling earlier, and historically OpenAI has really kind of been behind there. And GPT-5 seems to have really raised that bar. So now a lot of the use cases that we would use a like smarter, more heavy reasoning model that we couldn't really before because the tool calling wasn't there. Those now open up for us. So I think that's where I'm really excited, is kind of pushing the boundaries of how we can use a strong reasoning agent that can also call tools well.
Yeah. And this is like the first model that we've tested for which it's like an actually a contender for that main agentic driver.
Yeah, it is. And there's going to be, it's going to take time to really tune it and to like figure out what it's good at and like figure out whether this is something that can provide the same quality of experience that Sonnet does. But early signs are promising, like early signs are exciting, and like exciting enough that we decided to put it in front of users and get their takes as well.
Yeah. And the thing that you mentioned about it taking some amount of time, I think that's especially salient because I think it's almost dangerous to say like, okay, we have this existing model harness that's been kind of like tuned for one class of models, mainly like Sonnet and Opus, mostly Sonnet. And to say like, okay, like here's a brand new model, let's drop it in and expect it to just, just work as well, much better. It's dangerous. I feel like if you do that, it can maybe give you a false impression of the model's actual underlying capabilities.
Oh yeah. Yeah, absolutely. As I'm doing this, like the thing that I have to constantly keep in my mind is like trying to not evaluate models for a specific use case, but rather like try and use the evals as a way to pull out what models are good at. Because we're changing so quickly. So like the scope of problems and the types of problems that these models can solve is also changing quickly.
Yeah.
So being open to a model not performing as well our benchmarks that we kind of arbitrarily decided on,
Yeah.
and finding the things that it really shines at. I think that's where there's a lot of opportunity to kind of build alloys of models that that lead to a better overall experience.
I like that term alloy too.
Yeah. Did you read that paper?
I did. There was a paper, and then there was also like the Expo blog post. I don't know if you saw that as well. But that was like alloys are this idea that you can combine multiple models in sort of like the same inference chain, and almost like counterintuitively, this yields better results than using like one model or the other. And I say counterintuitive because it's like you're switching brains midstream, right? And you would think that a completely separate model would have more trouble, reasoning over tokens generated by a different model, because in theory, the perplexity is higher, and that's typically correlated with like lower quality output. But there's been some research that shows it's exactly the opposite, and you can speculate as to why. Maybe it's like more diversity of tokens, or maybe it's like closer simulation of like human output or something. But like there's something about that I don't know. It's an area of active research, and it's something that I think we're excited to explore.
I'm really interested in this because we've like kind of had a poor man's alloying with the Oracle. Like,
Yeah, that's true.
like using the strengths of Sonnet to generate stuff quickly
Yep.
and like get something working, and then using the reasoning power of O3 to kind of be a second opinion. So like that side of the intuitively makes sense to me, but like mixing the tokens together is just
it's
deal journey.
Even we haven't gone that far, but soon, it's everything's changing, as they say. Cool. I want to talk a little bit about how our own impressions of GPT-5 have evolved, because I think this speaks to the model evaluation process. So, like I have my own thoughts, my own like first impressions of GPT-5, but like what were yours? Like when you first got access to the model, what was the initial?
I mean, yeah. So the first thing I did was just plug it in Beyang, right? And it was kind of awful.
Right. But in what ways? Like,
so like our system prompt is very tightly tuned to Sonnet, right? It corrects for a lot of Sonnet isms that either don't exist in GP5 or like really push GP5 into kind of dangerous and weird, not dangerous, that's a bad word, but weird territory. Like, so like our talk about like our prompting around succinctness, right?
Yes.
GPT-5 took that very literally.
Yes, I remember that. It was like emitting like forward responses.
Yeah.
Not even like grammatical, right? Like it's just like blip, blip, blip.
Why use more words when few do responses?
It's very instructable, right? Like which is a big delta from I think like our experiences with Sonnet, especially like 4 is much better, but like 3.7, I think the common complaint was that it disregards instructions because it wants to do its own like agentic.
Yeah, strong personality.
Yes.
Yeah,
strong constitutional personality, I think that folks from Anthropic would say.
Yeah, absolutely. Other things like another example of this is we instruct Sonnet to like link its responses to the relevant pieces of code, and when it works great, it's really nice. But Sonnet does that very inconsistently. And I toss that same prompt chunk into GPT-5, it responded great. And so this is something that I'm excited about, is less more pliable prompting. Just kind of being able to get it to do things that it isn't doing out of the box more easily.
It does seem more steerable and definitely like follows instructions, like you said, almost to a fault. But again, this is coming from like an indexing on Sonnet world, where if you want to steer it, there's certain instructions it really doesn't like to follow, and that requires much more like intentional prompting. Doesn't seem to be the case with GPT-5.
Yeah. I mean, another example on Sonnet is like emojis. Like,
Oh,
try to get rid of emojis.
Yeah, Thorsten hates emojis.
Yeah, I don't think I've seen a single emoji in GPT-5 so far.
Yeah,
Thorsten will be happy.
Yeah, and no, you're absolutely right.
Yeah.
It's much more like personality-wise, Sonnet feels Sonnet presents almost like a patina of high agreeability, high agreeability, right? Like, you're absolutely right. Whatever you say, that's great. Underneath the hood, it doesn't actually want to obey as many instructions, whereas GPT-5 feels more like, it's less nice on the surface, but it will actually do more of what you tell it to do. At least that's my general impression.
Yeah, the interesting thing there is like one behavior in GPT-5 that I've struggled to prompt out so far is kind of asking the user for permission or input to proceed.
It wants the human to check its work in a lot of cases.
Yeah. So I'm sure there's probably a way to prompt this out. I haven't figured it out yet. But I think that's another characteristic that's interesting that I've seen.
Yeah, that's interesting. So my first impression of the model, I did basically what you did, is drop it in, and there wasn't really any customization. And the first thing I noticed was, I had to run on some simple task, and then like I alt tabbed away to do something else. And I came back later, and it was still running. It was still running like the first search query. I was like, why is this so slow? And it turns out that like I think the model with the kind of like Sonnet scaffolding, it just had a greater propensity to issue queries that were like full natural language questions to our search subagent. Whereas Sonnet, it typically does more keyword searches, or its natural language queries are more succinct. And so with the like longer natural language queries, our search subagent would just take that and just run with it. And so it would kind of like spin and spin and spin, wanting to kind of like cover all the possible paths of what the user might be looking for. And the upshot was it just ended up taking much longer. And so like that's another thing that we had to tune.
Yeah. So like the verbosity it took a little bit of work, but I talked to some people at OpenAI, and they like have this new verbosity part in the API, which we're not actually using because we can just prompt it and be more specific about how verbose we want it to be. But it was something that like GPT now responds well to. So it took a little work, but
yeah. And I think we're still, we've had access to it for a couple weeks now, and so we made a lot of progress from those initial days, and I think it works really, really well now. Like, I'm really excited. I'm gonna use it as like my main driver for a week and see how it goes. But I think we're still at like the very tip of the iceberg, because going back to you made much earlier, it's like we're no longer in the days where you can just like drop a model into application scaffolding and be like, okay, now it's in the model selector and have at it. I think at least our takeaway is that you have to be much more intentional about making sure that there's the right kind of like scaffolding around the model. Otherwise, I don't know, like everything comes down to the user experience at the end of the day. And like, as tool builders, like, that's our contract with the end user. It's like a good user experience, something that you can use day to day, and it's not frustrating. And it does take a fair amount of tweaking.
Yeah. And I mean, I expect to be doing a ton of tweaking still, like over the next week or two. Like, there are still plenty of things that I want to fix. But the nice thing is like, it's good enough now that I can use it for my day-to-day tasks. which means that the behaviors are more discoverable.
Yes.
So there was definitely like a threshold below which it was just frustrating. Like it felt like I was getting such poor results that I wasn't even able to push it to do what I wanted better because I didn't even know why it was working so poor.
Yes. As you're right. Like the threshold is like, as soon as I can get this point, like maybe it takes a little bit longer, maybe it takes a couple of like behavior shifts on my end, but as long as I can get it to the point where I can like have it do stuff and then push it, that's night and day from like, oh, it didn't work and I can't get it to work. And so ergo I have to like fall back to not using it. Because like I feel like part of making this work is also, it's like this human reinforcement learning, right? And so until it gets good enough to be like used in the everyday like reinforcement learning process as a human, you're going to get like a limited amount of feedback, or it's going to be much tougher to iterate on the prompting and the tool descriptions and all that scaffolding.
I'll be really interested to see like how our users react to it because even with all the tuning, like it's not going to feel the same with Sonnet. It still has its own personality.
Yeah.
But like I've found I was initially really frustrated even after I got it working reasonably well because I was so used to sonnetisms that like those have ingrained themselves into my workflow.
Yeah.
So like when GPU doesn't react the same way, like what are you doing? This feels wrong.
Like the positive reinforcement.
Yeah.
I totally get that. I part of me wonders. So, like, one of the things that's really exciting is the high degree of instructability, which we've already touched upon a little bit, and I think like that has implications for use as like the main agent driver, which is like that's an experiment that'll effectively play itself out in like the next couple of weeks as we see how users react to it. But the instructability aspect of it is also exciting because that potentially opens it up to being much more versatile in the use of subagents because it's more tunable, it's more instructable. And so I wonder if now we'll see a kind of like proliferation of subagents that are targeted at different subtasks, like, you know, search and retrieval or explanation at different verbosity levels or in different like personas, because GPT-5 it does seem to obey instructions pretty well in terms of like, you know, what you want it to do, how you want it to behave, the style in which it answers.
Have you had the chance to kick the tires on the smaller models that were released today?
No.
Okay.
Yeah. Have you?
No. I run request against them. So,
Yeah.
But I'm curious if they have the same properties of GPT-5.
Yeah.
Like a little less stupid or a little more stupid and a little faster.
Yeah. That is also interesting. Did you tried it with GPT OSS, right? Or like someone did.
Yeah, I think Nico maybe, but
okay.
I haven't played around with the OSS models much. I've been very focused on GPT-5.
Yeah. That's the big moment. This week. Cool. Well, like, where do you think the path goes from here? Like now we have kind of like 2 top level models within AMP. There's a lot more exploration to do. There's also these like open source models that are quickly closing the gap. You know, what's next on your plate in terms of like evaluating models? What are you most excited about?
Yeah. So right now I'm excited about kind of productionizing the bits that we've got in the pipeline. So like finishing tuning GPT-5 as much as that's ever a finished job. Like running it through more rigorous evals and getting user feedback across a more diverse set of tasks. But then the other big thing that I'm excited about is like exploring the speed dimension. Like I said, that's one of those that could really change the UX of these tools. And I would love to see how far we can push that. And like, I mean, AMP's usage-based model makes this easier to experiment with because we don't have to worry about this being profitable.
Yes. we don't have a cost constraint that would close off like some areas of exploration.
Yeah, exactly. So like, I mean, at 2,000 tokens per second, you can burn through a lot of cache, and it's super fast. So if you're only doing 200 tokens, that's fine. But like, I mean, for me, I'd be happy to burn through a bunch of cache to get my job done more quickly.
Yeah, it's like if you could get sort of like real-time feedback, but at the level of quality and robustness that we currently see with like Sonnet and GPT-5, I feel like that would change the game again. Like that would be like a step function. It would be like qualitatively different because of, I mean, there's the whole, what do they call it? Like the different thresholds of like latency at which the human brain like perceives it. If you get it to within the range of like couple second latency for like most tasks, it almost addresses one of the key pain points in agentic coding that I see now and feel personally, which is the distraction effect.
Yes.
It's kind of like you're waiting for it to do.
Do I tab over to Slack?
Yeah, yeah. It's like you tab over to Slack and then you get sucked into the Slack thing, and then you're like, oh crap, it was doing something. Let me go back, and then you have to like page in a bunch of context again.
Yeah, the threshold that I care about is like, do I switch to another window? Like if it can keep me engaged enough that I don't leave and like am following along with what it's doing because it's doing it fast enough that I don't care. And even following along, like that's going to be a UX thing to solve.
Yeah,
we're generating this fast.
Yeah.
Like I can't keep track of tens of tool calls being called in 5 seconds.
Then it's just like, okay, let me just see the diff it generated, and we'll see if it was right or wrong or on the right track.
So I think we're gonna need like new UI abstractions even.
Yeah. Or there's just like certain elements of the UI that don't have to like take up user attention and make it seem like you're not waiting. Like the whole streaming text thing, let's be honest, it's just the way to show progress and holding your attention so that you don't get bored. Because if they're like, if it rather than streaming text, if it just like had a spinner and you had to wait for the whole thing to appear at once, I think people would, the lived experience of AI would be a lot less like magical.
Yes.
And I think it's also kind of like I'm optimistic here because like you said before, it's like the open source models are super fast. They're not quite there yet for the full agent stuff, and who knows how long it'll take to get there. Maybe like next month we'll be there. Maybe it'll be like 6 months from now, or longer. But I think I'm very optimistic that for like these specific tasks like search, we'll be able to get them to a point where they can work just as well, but be a lot faster. And I feel like I don't have hard stats to back this up, but I feel like a lot of times I'm waiting. It is for like a particular like search sub agent run to complete because it's doing its thing, right? It's finding the context and
also it goes back to the like you're not showing streaming progress because it's all collapsed.
Yeah, that's true. It's like like you have less patience for the sub agents in AMP because we try to make the interface less noisy. Yeah, interesting. Okay, one last thing that we haven't discussed yet, the whole like evaluation process, like quantitative evals, qualitative evals, vibe checking. What is kind of like your process and philosophy for evaluating models?
Yeah, so I'm really heavy into qualitative evals. Like basically every time I've looked at a quantitative eval and tried to get any useful information out of it, I fail. Because like the number of dimensions that we're trying to measure in order to like come to the best user experience, it's too many to condense into any single number or even like a set of numbers that captures how this actually feels. So like to the extent that I care about quantitative evals, it's like is this good enough even to like land in our in our radar. And like there's enough out there that I'm comfortable depending on those to kind of do the initial weed through of
This is like the phone screen, right? It's like to kick the tires, and
that's a great way to yeah, so like, and then the other side of this is to give models the best chance, you really have to work with them, right? Like you have to do the tuning ahead of time in order to even see how they could perform on the types of tasks that we're throwing in it. So we have built out like a standard set of tasks that we manually run it through and like run it through many times and tune the prompts as we go and kind of take notes about like features of the models that we see, because like we talked about earlier, not only do we want to pick the best models for specific tasks, but we also want to find what models are good at so that we can slot them into the more specific things.
Yeah.
And if we're just measuring for the specific things that we care about, then we'll fail to discover the bonuses.
Yeah. It's like if you try to reduce the dimensionality of your evaluation criteria too much, you basically setting yourself up to like miss any sort of like new capabilities or possibilities.
Yeah.
Which is very dangerous in AI land because new things are emerging like every month.
Yes, absolutely. Yeah, and we have to basically change our eval set every time a new model dropped.
Yeah.
Which kind of defeats the purpose of an eval set.
Yeah, totally. It's like, oh, it didn't pass on this, but the vibes feel good, so let's make it pass. And then it's like, what are we even doing at that point? Yeah, I think that's right. So what is like a qualitative eval then? Is it just like a workflow that, you did at some point and now you just wanted to do it again? And
yeah. I mean, I always start with like a vibe check, just throwing it in and using it for my daily tasks. But then it's kind of a set of scripts. Like I maintain a couple open source repos. I nab a GitHub issue from there, throw it at AMP and say like, all right, fix this. And then sometimes like another dimension is heavily prompted, like go through this checklist. Other dimensions are like how well it uses subagents to split up large tasks, or how well it selects the most useful tool for a job. Those are things that like I don't necessarily want to force it in any one direction, because they can choose different paths, and that's okay. Like GPT-5, for example, doesn't seem to like running our code-based search agent as much. But it can run a bunch of parallel searches at the same time. So it ends up being okay.
It's almost like, I feel like listening to you describe this, it's like the role or the job to be done here is like you're a model taster. It's like, you've thrown all the ingredients.
Model sommelier.
Yeah, exactly. It's like, it's subagent use, but with more from this region. Yeah, it's funny too, because I feel like like developers were very technical people. We always like to be very scientific and data driven, but a lot of it does come down to art more than science. Even if you talk to like ML researchers now, like model researchers, talk about like, how do you know at what point in the training process do you know if it's ready? I feel like you hear like similar echoes there. It's like, you halt training, you try the model with existing weights, and then either you keep going or you make adjustments along the way. There is no like scientific method where you just like turn the crank, and it's kind of interesting.
Oh, it is. And like, it's frustrating. Right? Like trying to do this and like not be able to build a graph of my results. Like, frustrating.
I think that's one, and we've discussed this before. That's one area where quantitative evals do seem useful. It's basically like unit tests or like regression tests, where like you're trying to explore some new area and get it to work for that, but you don't want to get into this like whack-a-mole state where there are these other existing use cases that are really important. You want those to remain robust.
Yeah, absolutely. And that's kind of what the setup scripts that I'm talking about acts as.
Yeah.
Because even if they're human driven, they still act as like a set of regression tests. The things that I really do like quantitative evals for, though, are like more observational analysis. So like even if its not number goes up, and being able to look at trends across like many runs is really useful. So like even if tool call counts, or like, I mean, latencies are one of the really hard measurable things that we still have. And then like things like number of lines generated, even like how wordy the models are. Those are interesting, and like aren't something that you necessarily be able to just pick up on if you're not looking at it across a broad set of samples.
Totally. Sometimes those point you in the direction of like, oh, it's going to behave like this, or maybe it reinforces some kind of like vague impression that you have. Like, oh, this seems more verbose. Does the data bear that out, or am I like hallucinating something here?
Yeah, absolutely. Kind of hints you in the direction of what might be worth pursuing.
Yeah, totally. I also think it's interesting because I think one of the things that over-indexing on quantitative evals does is it makes it seem like it's like a horse race, or like any sort of race, right? Like where there's like one winner, first place gets the gold medal, and then everything else is just useless. And I feel like with agents, especially, we might be heading into a world where, each model has its own set of characteristics and strengths. And so maybe it's no longer going to be the case where it's like, the main model that you use that gets like 90% of your day-to-day usage is just one model. We don't necessarily have to, like when we're evaluating GPT-5 over the next couple of weeks, it's not like the decision in front of us isn't like, Sonnet or GPT. It's more like, let's actually understand the strengths of each model, and let's see how human users react to it, how they change their behavior to unlock its capabilities. And then we just had to figure out how to expose these things in the application in a way that like steers people toward the sweet spot of each model, I guess.
That steering is a really tough problem too. These tools are so wide open in the types of problems that they can solve that like, I mean, everyone on the AMP team uses AMP extremely differently.
You notice that just scrolling through the thread feed, it's like who's got the like 100 message chain versus who's doing the kind of like short, sweet, like sniper shot.
Yeah. And I mean, I'd call us all expert AMP users, but like trying to then even give recommendations for how to use AMP is difficult because we don't all agree.
Yeah. And it's one of those things where like, I think philosophically too, we want to make a power tool, right? A power tool that's easy to use, but it's got to be a tool that, I don't know, like different people are going to use it very differently. And I don't know, do you have thoughts on like how to do this properly? I mean, I challenge so far, but
no,
like,
it has. And like, I mean, the thing I always try and keep in mind is that like you can have a pit of success that users aren't forced to fall into.
yes,
Like a golden path, but you're allowed to stray. Like,
yeah,
so I mean, we've kind of gone down this direction with our public blog posts, right? Just this is how I use AMP. It's not prescriptive, it's descriptive.
Yeah.
Which I think works well and gives people ideas.
Yeah.
Without kind of baking it too far into the product.
Yeah. They're almost like recipes where like, if you're first starting out, try this, and then you can kind of evolve things. The phrase that comes to mind, like, like I think it was like this came from Thorsten originally, which is like you want to cut with the grain of the model. So it's like each model has a sort of like natural behavior that like it wants to do things in a certain way because it was trained to do it in that way.
Yeah.
And you really don't want to go against that because then you're kind of like fighting against its nature. But like the set of things it can do is potentially vast. I mean, there's like billions and billions of parameters. Um, it's yeah, I don't know. Like I hate to over like anthropomorphize, but in some ways it does feel like working with a human being, right? Like every human is going to be different.
Yeah.
And when you start to work closely with someone, it's more about understanding their unique talents, their strengths, their weaknesses, and how to like communicate with them.
Yeah.
Um,
I mean, that's why I used the word personality earlier.
yeah.
It's like you get to know the sonetisms and grow to depend on them. But there will be GPT-5isms. There'll be uh, Gemini-isms.
Do you have any inkling for how to make these choices salient to the user at a top level? Like, I think we're, we've been very like public about like, no model selector, at least not in the way that it's been implemented for like chat-based LLMs.
Yeah, so I mean, I think that's still the right choice just because of how sensitive these are to the system prompts. Like we just can't build something that works for every model well with its own unique set of system prompts. But like, I really like our subagent model.
Yeah.
Where I mean, it keeps the agent isolated in its own little box, and it's clear to the user that this is something different and behaves differently, and it has a name. So like, the oracle is a name describing what it's meant to do.
Yep. And it's distinct from the model name, which today it's O3, but we were just discussing like, maybe it's time to change, especially because there's certain behaviors in GPT-5 that seem, especially on like high reasoning mode, right? Which seem like it could be competitive or better than O3 in some cases.
Oh yeah, I don't think it'll be a hard switch.
Yeah, and then it's like, you've changed the implementation to make it more or less like strictly better. And at that point, it's like an implementation detail. You don't need to surface the underlying model identifier to the end user. Because like, honestly, it's not just the model you're changing. It's also like the tool descriptions and the construction of the agent and the code that surrounds it too. So yeah. Anyways, there's a lot of work to do. We should probably get back to it. There's a lot of stuff to explore, especially today. I don't know, any final kind of like parting thoughts?
Yeah, I'm excited to see how Anthropic responds.
Yeah, and I think there's a lot of great people there, insanely smart, and I just feel very fortunate to be in this position. I mean, living at this time, sometimes you get like pinch yourself, like what time to be alive, and it's great to have so many like intelligent people advancing the frontier of the models. Yeah, everything's changing and everything is going to continue to change. I don't think there's like an end in sight yet.
Nah, here for the ride.
Cool. All right.